Okay, rockin', and we're back. It's been a hot minute. That's pretty normal. Let's see here. So today we are going to continue working on what I've been working on for the past few days, and that is our filter pushdown. Um, and so this is a continuation of yesterday's stuff, and so let's just kind of go from there. So, this is Comet. That's not what I wanted. I wanted Spark. Okay. Ooh, okay. We should do a commit, I think. Okay. Git commit dash am. I should have committed this before. Okay. Simplify alias use tracking. Simplify alias use tracking. Simplify non-alias filter pushdown. Switch to map from attribute map. Yeah, simplify left behind alias tracking. What else did we do? What else did we do? Okay, yeah. So now I want to really what I want to do is I want to talk through this test case here that's broken. And it's broken, and I think legitimately we could say like, hey, you know, this should be broken and we should change the behavior. But I was thinking about it last night, and for cheap filters, that is, or filters that we can probably evaluate at ooh, I should take my morning multivitamin. For filters that we can probably evaluate or might be able to evaluate at the storage layer, we don't care about double compute. And that's fundamentally that's important, right? Like if we can evaluate a filter at the storage layer, we're not actually having a double compute situation, which is what a lot of this change is about avoiding. And since we don't have a double compute situation, we should push that through. But that doesn't. It's easier said than done, I guess. Is the TLDR. I'm gonna go here and take a look. Okay, cool. So that's, anyways, I think it's important. I don't know if we can avoid it. I don't know if it's reasonable to attempt to move this work forward without avoiding it. So that's what we're gonna do. We're gonna take a look at this and think about how can we figure out if a filter might be evaluable by the storage layer. And I think there actually is possibly this thing here. The ordering of filter predicates isn't reasonable. And their solution involves, this is probably the latest one. Their solution involved looking at what filters could be pushed, I think. Right? Is this right? Or, oh, is that not actually what they did? No, this is not what they did. Does this apply to everything? Um, filtering predicates that need to be evaluated. Right. Okay. Not quite what they did. Similar thing where it's like, you know, ordering of filters and doing things more intelligently. So we got a few different options of sort of how we could go about handling this. One is we can take my sketchy hack, which goes like, hey, if this filter is cheap, we're just gonna push it. And the other one is if this filter is expensive. The other one is like looking at what is the relation, and does it support this kind of filter push down. And that one might be a little bit too involved, but it might not be. So filter can evaluate filter. So essentially what I would love to do here is say, hey, let's find our base relation, and if our base relation can evaluate this filter, we're gonna go for it. Although let's take a look. It's private. Can evaluate. Where is can evaluate called from? It's called from push filters. Ugh. And unfortunately, this sorry, I'm trying to swear a little less. This push filters mutates in the data source. That is most inconvenient. Is there a copy method I could use? So what could we do? What could we do? One thing is we can make that thing that's private public. We can make it more generally public. Probably wouldn't go over super well. What else does this use? Can filter. Okay. Copy. And I don't want to copy the row. I want to. Okay. Well. So what would we do here? What tool would we need? We would need find the Okay, let's go over here, and we're gonna go in this case. Alternatively, if something is changed, we might still want to push the filter if the table has a chance, could evaluate the filter. Okay, in-memory scan builder. Hmm. Hmm. So it's a class, not actually necessarily possible to copy it. So unless we change can evaluate, or we've got a new scan builder. What is the type that we've got in here? Extract. Okay. This is going to fail, but it'll tell us what the type should be. But oh, hey Taniwa. I can see you are also very excited for the Kubernetes release, and thank you for subscribing for so very long. Really appreciate that. Okay. Best cube release ever. Best cube release. Okay, cool. So we're gonna take a logical plan. What can we do? I don't need to resolve anything. I don't want to refresh it. Oh, yay. Oh, I'm so glad. That's awesome. That's awesome. Okay. Wait, there's release stickers? Oh, I'll definitely have to ask. I did not realize there were release stickers. References, deterministic, transform expressions. Oh, yeah, okay. don't really want to transform expressions with pruning. I mean, maybe we do want to do. Oh wait, okay. To each expression. Oh no, that transform all expressions. Okay. Okay. We're gonna have a good one. Have a good one. So yeah, let's see if we can. All right, correct. Okay. There we go. Okay, so found oh so not quite what I want. Do, do, do. I want to get. Is it going to be all the subqueries? Uh, Def collect with subqueries. Okay. Well, let's go ahead and get subqueries. Yeah, sub. Yeah, okay. Subqueries. Nope. No subqueries. Hmm. Okay, sorry. So what I'm thinking about right now is like, what do I want to do here? Because like if, for example, we were talking to JDBC driver, we might want to grab just everything and push it down to JDBC because it can evaluate everything. But I got a theory, and by a theory I mean, okay, infer filters from constraint suite. Infer filters from constraint suite. Generate dot select sign X, sign Y, plus $. Wonder if that means it would show up as a subquery, because it might not show up as a subquery because it's the immediate parent. Maybe it, I don't know. Yeah, well, whatever, let's find out. Why is this taking so long? Did I run a clean compile by accident? Fudge. Oh, I just ran compile, so it's recompiling everything. Oh well, that happens. That happens. Okay. There we go. Catalyst test only. Taking so long? And the catalyst test. There we go. No. I don't really want to go through the children manually. See what else goes through the children for us. Wait. Okay, children. It's the metadata. Yeah, okay. Fine. Sequence of table. Or we'll do this as string for now. Okay. So I guess. Okay. Table. Not table. Okay. Let's see here though. I don't know. Oh, no, not found table. Okay. Ah, all right. Um, dude. Table. Object in Scala. How do we get the type of an object in Scala? Don't remember. Cool. Let's see. I don't think it's going to be table, but we will find out in a minute. God damn it. Why did I run compile? I didn't want to run compile. I wanted to run catalyst test. I was going to compile. Fucking hell. Yeah. Okay. Okay. These? No. Sure. Say yes. Okay. Extract the tables from a query plan. Figure from a query plan. Use this to determine if a table might support a filter pushdown, in which case we should always local relation. Let's see here. What does local relation? Use a leaf node and it doesn't. Yeah, I'm not loving where this path is sort of taking us. It's getting complex. Local relation. Helper. Where do we? Yeah. So, wait, yeah, local relation is just a leaf node. And so we're not actually going to necessarily, um, insert filter. Can push through condition. Through join. Okay. V2. No, column pruning. Sure. Aggregate, expand, merge rows, join, project nested column aliasing, projection before filtering, collapse projects, expression, collect references, renaming, optimize repartition. I'm looking for something. What I'm doing right now is I'm going through and I'm looking for something which is doing something similar to what I want to do, right? And that's tricky because I'm lazy. Push down predicates, filter over an aggregate, filter over a union, a watermark, unary node. Push down. That's all. Where do we do our, this is pushing through joins. Or is this happen somewhere else? Alexa, stop. Alexa, create a 3-minute timer. Alexa, create a 3-minute timer. Great. So, I don't love this. Maybe we do the hack where we just push cheap filters through always. How do I get the table? And how do I check if the table can support it? Right. Eval inline tables. Yeah, that was all us. Like pushes the filter. Okay. Let's see here. For parquet filters, this is I don't know. off the top of my head. I'm sorry. Okay, Parquet filters is implemented inside of something called filters.scala. Okay. Where is Parquet filters called? Yeah, okay, data source v2 strategy. Okay. We take this and we apply it to a plan. Alexa, stop. Where does the filters come? Okay. Place table as select, create table as select. Oh, that's going to be the right side. Right. Data source v2 scan. Sure. So this doesn't necessarily take the filters, right? Okay. So I don't know super how to do what it is I want to do. It's annoying. Prune columns. Yeah. So yeah. Alright, leaf no SQL dash I data source v2. There we go. Data source v2 relation. Nope. Data source. There we go. So it does not necessarily have a lot. So data source v2 relation. File data source v2.scala. All right, this is okay. Ugh. Quarters. Hmm. Um. Maybe JDBC relation provider. Okay. There we go. So if it's an instance of pruned filtered scan, is that what I want? Pruned filter scan. If this is really, let's okay. So inside of interfaces.scala, inside of sources. Cool. Yeah. Okay. So I think what I need to do next is we're gonna go back to the other test and we're gonna make a different instance of uh, the local relation or whatever. Does local relation implement? Yeah. It does not extend base relation. That's frustrating, but we'll find something that extends base relation and we'll make a custom version of that for testing so that we can test this like pushing down concept. And that is what we will do. Cool. Okay. Sorry we didn't get very far. I'll be back probably this afternoon to try and finish it up.